Good morning, students. So example 6.34, find the parametric form of vector equation of a straight line passing through the point of intersection of the straight lines. R vector is equal to I cap plus 3j cap minus k cap plus t into 2i cap plus 3j cap plus 2k cap, and x minus 2 by 1 is equal to y minus 4 by 2 is equal to z plus 3 by 4, and perpendicular to both straight lines. Okay, so we have to write the parametric form of vector equation of a straight line passing through the point of intersection of these two straight lines. Okay, so the required straight line passing through the point of intersection of these two straight lines. Okay, so the given two straight lines on this one, the first line is in the vector form and the second one is in the Cartesian form. Okay, so first we have to find the point of intersection of these two lines. Okay, to find the point of intersection of the lines, so first you have to consider the first line which is in the vector form. You have to convert into Cartesian form first. So see that it's a passing point of the first line and this is the parallel vector. So in the Cartesian form, how the equation will be? X minus x1 by b1 is equal to y minus y1 by b2 is equal to z minus z1 by b3. So here your x1 is 1, x2 is 3, and so x1, y1, z1, that is 1, 3, minus 1, and b1, b2, b3, that is 2, 3, 2. So if you substitute in the formula, x minus x1 is 1 by b1. What is your b1? 2. Okay, which is equal to y minus y1. What is your y1? 3 divided by b2, that is 3, which is equal to z minus of minus 1. So z plus 1 divided by b3. What is your b3? That is 2. So we have written the vector equation in the Cartesian form. So how to find the point of intersection? So first you have to find the points on the straight line, the arbitrary points on the straight line. At the point of intersection, both the points should be equal, so you have to equate. From that you have to find the values of s and t, and you have to substitute in the corresponding equation. You will get the point of intersection. So for that, the Cartesian form of the straight line, I am just write as it is equal to t. From that I am going to find the point on this straight line. So that is x, y, z we have to find. How you take the first term when it is equal to t. So x minus 1 is equal to 2t, x is equal to 2t plus 1. In the same way, y is equal to 3t plus 3 and z is equal to 2t minus 1. So I have completed, I have found the point on the first straight line. Okay, so take the second straight line. Already it is in the Cartesian form. So I have considered this and it is equal to s. So we are going to find the point on this line. Okay, so you have to find x, y, z. So at the point of intersection, how the points, these points are equal. So we have to equate the points. Okay, so the x coordinate, when you equate, 2t plus 1 is equal to s plus 2. And 3t plus 3 is equal to 2s plus 4. And 2t minus 1 is equal to 4s minus 3. So you have to form the equation. So ts, we have to take it to the left side and bring the numbers in the right side. So you will get how many equations? 3 equations. You just consider any two, and if you solve, you will get the value of either s or t. Okay, so I have considered the first equation and the third equation. So when I change the sign, this 2t and minus 2t getting cancelled. So here you are having minus s, here you will have plus 4s, so that is 3s, which is equal to 1 plus 2, that is equal to 3. So s is equal to 1. Okay, so after finding any one value s is equal to 1, we have to substitute in the corresponding point. What is the corresponding point? So it is s plus 2 2s plus 4, 4s minus 3. So when you substitute s is equal to 1, this will become 3. Here you will have 2 plus 4, that is 6. Here 4 minus 3, that is 1. This is the point of intersection. So see that your required line passing through this point. Okay, and you see that your required line, how it is perpendicular to both the straight lines. So to write the equation of the required line, we need two results. One is passing point and parallel vector, or otherwise we need two passing points. Here just now we have found one passing point. Here what is needed? You need the parallel vector for the required line. But what is given? Your required line is perpendicular to both the straight lines. So from these two straight lines, you have to collect the parallel vector of these two straight lines. Okay, so B vector and D vector has to be taken from the two lines. B vector cross D vector is only the parallel vector to your required line. Already we have discussed the same thing in the previous video. So from the lines I have collected the vectors. From the first line, this is your A vector and this is your B vector. From the second line, so in the numerator, so it is 2i cap plus 4j cap and minus 3 cap, that is your C vector. And your D vector is I cap plus 2j cap plus 4k cap. So here we are having B vector and D vector. Now what is needed? The parallel vector for the required line. So which vector is parallel to the required line? B vector cross D vector. Okay, so we are going to find B vector cross D vector. So cross product evaluation is, it's a determinant. In the first row you have to write I, J, K. In the second row, B components is 2, 3, 2. And D vector components is 1, 2, 4. So while you are evaluating, you will get your answer is B vector cross D vector is equal to 8i cap minus 6j cap plus k cap. So see that, if now what we got, the required line passes through the point of intersection of the given two lines. So what is it? 3, 6, 1. So one passing point. And your required line parallel to B vector cross D vector. So one passing point and one parallel vector. So what is asked? The parametric form of vector equation. So the formula is R vector is equal to A vector plus T into parallel vector. What is the parallel vector here? B vector cross D vector. So A vector can be written as 3i cap plus 6j cap plus k cap. And B vector cross D vector is given here. So here you can use T or you can use S. So S and T belongs to R. So we'll come to the next problem. Exercise 6.5, 7th problem. It's an important 5 mark for you. So find the foot of the perpendicular drawn from the point 5, 4, 2 to the line x plus 1 by 2 is equal to y minus 3 by 3 is equal to z minus 1 by minus 1. Also find the equation of the perpendicular. So see the diagram. So this is the given point. What is the point? 5, 4, 2. That is the given point to the line. Okay. So what you have to find now? Foot of the perpendicular drawn from this point to the line. So this is the, so here F is the foot of the perpendicular line DF. D is the head and F is the foot. So from this point, if you draw a perpendicular line to the given line, then your F is called the foot of the perpendicular. So you have to find this. Okay. And also find the equation of the perpendicular. So you are going to find the equation of DF. Okay. So see now, from this point, we have to draw the perpendicular line to the given line. Okay. And F is called the foot of the perpendicular. you have to find what is the coordinates of f, and also you have to find the equation of df. Okay, so the line's equation, the given line is in the Cartesian form. So from that I am going to find the vectors. So what is a vector? It is the position vector of the passing point. The passing point has to be taken from the numerator. So here you will have -1 and 3 and 1. So it can be written as minus I cap plus 3j cap plus k cap. And the denominator or nothing but the direction ratios of the line. So that is b vector is equal to 2I cap plus 3j cap minus k cap. Okay. So on the given point 5, 4, 2 I have taken as D. Okay. So F where it is also on the given line. So what I am going to do, so I consider the line which is equal to t, and I am going to find a point on this line, how it should be. So where you have to find what is x, what is y and what is z. How to do that? First term when it is equal to t, so you will get x plus 1 is equal to 2t, x is equal to 2t minus 1. Okay, in the same way you have to find y and z. So this point where it is on the line. So your f point also it is on the line. So f point can take the form 2t minus 1, 3t plus 3 and minus t plus 1. Okay, so after finding the f point, you see that you have to find the df vector. So what's the need to find the df vector? Now you look at your diagram, your df vector, and what is this? B vector. What is B vector? Which is parallel vector to the line. Okay, so the line is like this. So this is the parallel vector. So when you consider your df vector and this B vector, how they are? They are perpendicular. So when two vectors are perpendicular, we know very well that their dot product is equal to 0. So that is the results we are going to find. So for that, what is needed now? df vector. So using position vector, how you can write? OF vector minus OD vector. Okay, this is the f point. How to write OF vector? 2t minus 1 into I cap plus 3t plus 3 into j cap plus minus t plus 1 you can write. I have written and say 1 minus t into k cap. So I have written OF vector minus OD vector. Which is OD? This is the D point. So OD vector, how you can write? 5 I cap plus 4 j cap plus 2 k cap. Okay. So see now you have to do the subtraction. Look at this. 2t minus 1, here minus 5. So 2t minus 1 minus 5 into I cap plus 3t plus 3 minus 4 into j cap plus 1 minus t minus 2 into k cap. So when you simplify, it is 2t minus 6 into I cap plus 3t, 3 minus 4 is minus 1 into j cap plus minus t, 1 minus 2 is minus 1. So minus 1 minus t into k cap. So we have found df vector. What's the need to find df vector? We are going to use the result. Your df vector and b vector, how they are? They are perpendicular. So we have to use the dot product between them. So when you take dot product, it is equal to 0 because they are perpendicular. You look at your b vector. B vector is a parallel vector to the line. So go to the line and the denominator or nothing but the direction ratios of the parallel vector. So here we have written b vector is equal to 2I cap plus 3j cap minus k cap. You are going to take the dot product between b vector and df vector. So how to take the dot product? You have to multiply the same components. So see that I component of df vector is 2t minus 6. It has to be multiplied with the I component of b vector. What is here? 2. So it is 2 into 2t minus 6. The next one, you see that 3t minus 1 into 3 plus minus 1 minus t into minus 1. So minus 1 into minus 1 minus t, which is equal to 0. Okay. So 2 into 2t is 4t minus 2 into 6 is minus 12. plus 3 into 3t is 90 minus 3. Here minus 1 into minus 1 is plus 1. Minus 1 into minus t is plus t. So you see that 90 plus t is 10t. 10t plus 4t is 14t. So minus 12 minus 3 minus 15. Minus 15 plus 1 is minus 14. So 14t is equal to 14. T is equal to 1. So we have found t is equal to 1. What is in the question? What is f first? Foot of the perpendicular we have to find. Which is the foot of the perpendicular? That is f. So where f is in the form of f in terms of t. So here we have found t is equal to 1. So when you substitute t is equal to 1 in here, you will get f value as, you see that 1, 6, 0. You substitute here 2 minus 1, that is 1. 3 plus 3, that is 6. Minus 1 plus 1 is 0. So we have found f. Next, what is asked? Find the equation of the perpendicular line. Which is the perpendicular line? DF. So you are going to find DF. What is D point? Here 5, 4, 2. What is the F point we have found? That is 1, 6, 0. How many points here you are having? 2 passing points. So therefore, you can use the formula x minus x1 divided by x2 minus x1 is equal to y minus y1 divided by y2 minus y1 is equal to z minus z1 divided by z2 minus z1. So you take d as x1, y1, z1. So it is x minus 5. So what is x2 minus x1? That is 1 minus 5. So here I have written is equal to y minus, what is y1? 4. So y minus 4 divided by y2 is 6. y1 is 4. 6 minus 4, which is equal to z minus z1 is 2 divided by 0 minus 2. So when you simplify, you will get the answer. This is the equation of the perpendicular. In the same model, you will have the example. Look at this. Find example 6.37. Find the coordinates of the foot of the perpendicular drawn from the point minus 1, 2, 3 to the straight line. So in the example, the straight line is given in terms of vector form. Also find the shortest distance from the given point to the straight line. So here what is asked? It's a distance is asked. In the exercise problem, it is foot of equation of the perpendicular is asked. Okay. So the same way, D is the given point. From that point, we have to draw the perpendicular line DF to the given line. Your given line is parallel to this vector, B vector. And you see that you have to find what is F and what is the shortest distance between D and F. So for that you will consider the line, given line. From that, this is the A vector and this is your parallel vector B vector. Okay. So what is needed now? Your F is needed. Okay. So you have to convert this vector equation of the line in the Cartesian form. So therefore, this is x1, y1, z1. So it is x minus 1 divided by 2 is equal to, next one what? Y minus 1. So y minus of minus 4. So y plus 4 divided by 3, which is equal to z minus 3 divided by 1. So it is the Cartesian form. You have to take this is equal to t and you are going to find a point on this line which is in the form of 2t plus 1, 3t minus 4, t plus 3. And your f is also on the same line. So it is also in the form of f coordinates can be the same thing, 2t plus 1, 3t minus 4, 3 plus t. And you are going to find which vector? DF vector, because your DF vector and B vector, they are perpendicular. So perpendicular results we have to use. For that, what is needed? DF vector. DF vector is equal to OF vector minus OD vector. So you have to write it is in terms of vector minus what is your D point. So this is the given point. So it is minus 1, 2, 3. Okay, so when you write as a vector, it is minus I cap plus 2j cap plus 3k cap. And see the calculation, 2t plus 1 minus into minus plus. So plus 1 into I cap, 3t minus 4 here minus 2 into j cap plus t plus 3 minus 3. Okay, so when you calculate, it is 2t plus 2 into I cap plus 3t minus 6 into j cap plus 3 minus 3 getting cancelled, t k cap. So we have found df vector. Okay, so df vector and b vector are perpendicular. So we have to use the dot product is equal to 0. Dot product evaluation is same component has to be multiplied. So see that here the I component is 2t plus 2. It has to be multiplied with 2 plus here 3t minus 6. It has to be multiplied with 3. Okay, plus here the k component is t. T has to be multiplied with 1. Okay, this is 1. Okay, which is equal to 0. Okay, while you are evaluating, 2 into 2t is 4t plus 2 2s are 4 plus 9t minus 6 into 3, that is minus 18 plus t into 1, t is equal to 0. So 9t plus t is 10t, 10t plus 4t is 14t minus plus 4 and minus 18, that is minus 14 is equal to 0. So you are getting t is equal to 1. So t is equal to 1, you have to substitute in the f point. So when t is equal to 1, here 2 plus 1, that is 3. Okay, 3. And here 3 t is equal to 1 means 3 minus 4. 3 minus 4 is minus 1. Okay, 3 minus 4 is minus 1. When t is equal to 1, 1 plus 3 is 4. Okay, this is your f point. We have found the foot of the perpendicular. And what is asked? Find the shortest distance from the given point to the straight line. This is the given point. We have taken as D. And f point also we have found. So you have to find the distance between these 2 points. So shortest distance between D and f. What is f? 3, minus 1, 4. Okay, you have to use the distance formula. So it is nothing but square root of 3 minus of minus 1. That is what? 3 plus 1. So 4 the whole squared plus minus 1 minus 2. So minus 3 the whole squared plus 4 minus 3, that is 1 the whole squared. So that is equal to square root of 16 plus 9 plus 1. That is equal to root 26. Thank you, students.